Hello, this video is for Stat 210, handout number 9, and includes pages 1 through 9. All right, let's go ahead and get started then. Handout 9 will be using the U.S. Counties Demographics dataset, which is provided in our Google Drive for Handout 9. And this will cover Part A here, Handout 9 Part A. Okay, what we're going to be talking about in Handout 9 Part A is going to be summary measures for numerical data. And in particular, we're going to be talking about measures of position. So things like mean and median will be covered in this handout. So we're going to consider an investigation of median household income levels for households across the United States. I actually obtained this data from the Census Bureau using a couple of APIs that links are provided there. You can grab the dataset U.S. Counties Demographics from our Google Drive and open that up inside of JMP. Here's what that data set looks like here. It has 6 columns in it. Let me go ahead and just focus a little bit the screen here. It has 6 columns in it. Has 3,200 rows in it. So I got information from every single county in the United States. We also have Washington, D.C. in this data set, and some counties in Puerto Rico as well. So there's some additional data besides just the counties listed in this data set. The variables that I have here are household income, commute time, and then the percent of people 65 years or younger that are uninsured. We're going to look at household income here in Part A. All right, so real quickly, here's a map that I created using that data set. I did this actually in JMP, but I will show you along the way here how to create those maps. The dark green is going to be higher income levels. So what states appear to have higher income levels? You can see those out in the east there. So Maryland, Virginia, New Jersey, and we got Massachusetts, Connecticut up there. How does Minnesota, Wisconsin, and Iowa compare? We're pretty much in the middle of the pack here, maybe a little bit more darker green than some of the others. So the middle of the pack here is about 50,000. We might be a little bit darker than that, so maybe 55,000 or so. Oddly enough, North Dakota is fairly green here. Their income levels are fairly high, probably due to the oil and such that's found in North Dakota. Alaska also is somewhat darker green there. Again, probably due to the oil and such that Alaska has. All right, let's go ahead and get started. What we're going to do first here is just focus on the counties from Minnesota. So I'm going to reduce those 3,200 down to the 87 counties in Minnesota. So I want to take that big, large data set and just get Minnesota out of it. And what we call that when we're doing that is called a filter. So to obtain a filter inside of JMP, I need to select rows, row selection, and then select where. And I want to specify a condition. So I want to specify the state equals Minnesota here. So that's the condition that I want to specify. State equal Minnesota. And what that's going to do is, once we do that, it's going to select the 87 rows. So when we apply a filter, it simply just selects the rows. We then need to take those rows and create a subset. And to do that, I need to go under Tables Subset. Make sure that selected rows has been specified. And I will obtain a smaller data set or a subset of the original that contains only the information from Minnesota. All right, so let's go ahead and move over into JMP and show you those steps. So this is going to cover the steps on pages 2 and 3 of this handout. So first things first, I need to select rows, row selection, select where. And what this is going to do is apply a filter to this sheet or spreadsheet. Rows, row selection, select where. I want to specify that the state is equal to, and I need Minnesota here. And once I select OK here, it'll select the 87 rows out of these 3,200 that meet that condition. So here I have 87 selected. If we fly down here and look at Minnesota, those are going to be highlighted or selected. There they are, starting there. Now to rip these out or to create a subset, what I now need to do is select Tables, Subset. I want to make sure that selected rows is being identified here and say OK. And what that's going to do is create a new subset or a new spreadsheet that contains a subset of the original where the state is equal to Minnesota. So here's my information for Minnesota here. So I'm going to go ahead and minimize the original. And this is what I'm going to be using here, the subset for Minnesota, for my analyses. If you want to name it, you certainly can. So Minnesota demographics or something like that. And now I won't have to go through that filter process again. Okay, to create our initial summaries, what we're going to do is go underneath Analyze Distribution. I'm going to be considering the household income. So we'll place that in the Y columns box. Once I click OK, I actually get 3 different regions of output here. Region A kind of includes what's called the quantiles. Region B is the summary statistics, like the average, standard deviation, the number of observations would all be under Region B. And then C is the graphics part. Okay. So let's go over into Jump and show you how to do that. Analyze, Distribution. I'm going to put household income in the Y box here and select OK. I'm going to select Stack here, which will just turn the output the other direction. So from my red drop-down menu, I select Stack, and that'll turn that output the other way for me. And that's what our output looks like inside of Jump. Again, we have Region A here is kind of the quantile stuff. Region B has the summary statistics. And then Region C over here is the graphics. The other thing that I often like to do inside of Jump is to create a dot plot of the outcomes. So this is a histogram here, as we'll talk about. But how do I create a dot plot of the outcomes? I will show you that quickly. That is on page 5 of the notes here. So this is actually under Graph Builder. So let's go back to our spreadsheet for Minnesota here only. Select Graph Builder. I want to select household income. Place that down on the y-axis. Underneath jitter here, I'm going to select positive grid. So that just stacks the dots for me. Once you have that graph kind of built, you can say done here. And that'll create a dot plot for you. So in the notes, oftentimes I will use a dot plot for my discussions. So that's how those were created. Again, that's under Graph Builder. You can change the labels here. You can specify how low you want the axis to go and how high you want the axis to go. Just start double clicking on things and you'll find all sorts of ways to edit that graph if you so choose. Okay, let's talk about the information in, I think this first part that I'm going to cover is Region A here, the quantiles. So starting on page 6, the quantiles. These are just measures of position. So for example, A here is just going to be the minimum value in the data set. Now these are household incomes for the state of Minnesota, for the 87 counties in Minnesota. So we have one county in Minnesota whose household income is $42,439, and that is the poorest county in Minnesota. The maximum is another measure of position. That's obviously the maximum value in the data set. So we have one county in Minnesota that has a household income at over $90,000. Actually, it looks like we have a couple up there at $90,000. This is household income here. C would be the median here. That's the 50th percentile. And what the 50th percentile means is that 50% of the data sits below that point and 50% of the data sits above that point. So the median is the middle value in the data set. So here the median is right at $55,000, $54,645. So again, a typical county or the median county in Minnesota is going to have income levels at about $55,000. Now we can do more than just the median here. We could look at what's called the 25th percentile or the 75th percentile. What the 25th percentile here, just denoted by D on the graph, is going to be the point in the data. Okay, so if I start on the lower side and I just kind of march through the data from lower to higher, when I get to about $51,000, I'm going to have about 25% of the counties. That would be the 25th percentile. If I keep marching through and get to the 50th percentile, well, that's going to be the median because that's halfway through the data. If I keep marching through and get to the 75th percentile, then I'm going to be 3/4 of the way through my data. So 25% of the data sits above that point and 75% sits below that point. Now these values are commonly referred to as Q1, which would be the 25th percentile, Q2, which would be the median, and Q3 would be the 75th percentile. If we wanted to pick on something else like the 90th percentile, that just means that 90% of the incomes are less than $73,219. 90% of the counties have incomes lower than that level. So those are quantiles or percentiles. And those are all measures of position in a data set. We also have other measures that go beyond just a specific value. So the median is a specific value here. But measures of position can be used to identify where data tends to be condensed. So for example, the middle 50% of the data is going to sit between the 25th and the 75th percentile. So if we go back up here and look at between D and E, I'm going to have 50% of the data. So that's going to be kind of give me an indication of where the middle part of the data tends to be condensed. That middle 50% here is going to be between $51,000 and $59,000. Other ones that we use that are similar to this would be the 2.5 percentile all the way up through the 97.5th percentile. Reason we pick on those is because between the 97.5th and the 2.5, I have 95% of my data. So G here ranges clear from 45,000 up to 92,000. That contains 95% of my data. Anything that sits beyond that, so these two observations down here or these two observations up here would be considered unusual or extreme because they are outside of that 95%. Okay, one more common measure of center is the mean or the average. Now I use those terms interchangeably, and what the mean or average simply represents is the balance point in the distribution. So if all of these points weighed exactly the same amount, I would need to put my teeter-totter here or my fulcrum here at 57,530 in order for this data to be balanced. So that is the average household income level for the 87 counties in Minnesota. It's the 57,530. Some practical concerns about the average or the balance point. Okay, so the average or mean is adversely affected when the values in the distribution are not evenly dispersed above and below the middle. So for example, if these two household values, these are household incomes for 2 counties in Minnesota, if I were to actually just increase those by a lot, okay, just flip those up real high to 200,000, let's say. What's going to happen to the balance point in the distribution is that balance point is going to have to shift up in order to compensate for that large gap. Now, what this means, or what this tells me, is that the average or the mean is very much influenced by outliers. And in fact, if I made these two observations over here even more extreme, then this balance point would need to be shifted up even more. So the average and the mean actually chase outliers. Okay, the mean and average are influenced by outliers. Now the median, on the other hand, to compute the median, if we wanted to actually do it by hand, what I would do is just cross off the largest and then cross off the smallest, cross off the second largest, cross off the second smallest, and I just keep doing that until I get down to the middle. Now I can put those largest 2 observations anywhere out here. I can put them at 200,000, I could put them at 200 million. It doesn't matter because they're going to, when I calculate the median, those are the ones that I'm going to be crossing off first. So the median is not influenced by outlying observations or outliers. Now, when the government reports income levels or salaries, they often will do that using median salary. Or when they do home values, they actually report median home values. So if you were to go out onto a website, Zillow, for example, what they're going to be reporting is median home values because they don't want their measures to be influenced by a couple of really nice homes. So that's common practice when you have distributions that are known to be what we call skewed or known to have outliers. The best measure to use is the median, because it's not influenced by outliers. Okay, some final comments. In practice, the reason we compute summary measures is so that comparisons can be made. So for example, here I got income levels on Wisconsin, Minnesota, I guess I got Massachusetts there and Connecticut. Provide a statement that compares the incomes of Minnesota to Wisconsin. Without specific values, that gets kind of hard to do. We can say things like Minnesota is shifted up some. Well, how much is it shifted up? Well, you can see the minimum for Wisconsin is about, 37.5, whereas the minimum for Minnesota is about 42 or so. So it looks like it jumps about 5,000 or so. The maximum values, though, jump from about 80 up to 95 or so. So the maximum values for Minnesota are jumping up by about 15,000. So one nice thing about measures, summary measures, things like averages, is that I can more easily make comparisons between states here. So if I use the average, I can say that Minnesota incomes tends to be about 3,000 greater than Wisconsin. Or almost 4,000, I guess it would be. That should be about 4,000 there. That's a typo. Or Massachusetts and Connecticut incomes are about 15 to 20,000 higher than what I'm seeing in Minnesota and Wisconsin. So I can quantify how different the data values are using things like averages or medians. It doesn't matter. I can do things like rank the states. So what state tends to have the highest household income levels? Here I'm ranking based on medians. So DC here is the highest. New Jersey is also quite high at 75,000. Hawaii is actually quite high here. So if I want to do things like rank the states, I'm going to need to decide on some sort of summary measure to use to do those rankings. That's going to be really hard to do without summary measures. Okay, that does it for handout number 9, part A. Thanks.